So sklearn is nothing but it is a short form for scikit-learn. Okay, it is a magic toolbox in data science which provides us lot of things. Okay, using those we can get your data ready for machine learning models. Okay, what all this sklearn, what all this scikit-learn library does, it gives you ready-made tools to train machine learning models. Okay, that is what it will do. It is going to help you to prepare your data, and then it will also help you to evaluate your models. Okay, in future if you are planning to learn AI ML, so scikit-learn is something which is going to be very important for you. Okay, so in today's workshop you're going to learn what is scikit-learn, how to use this, using this how do we prepare the data. Okay, so now it's written in Python. This is written in Python. Okay, so it is very easy to use and it is also very popular and useful for both beginners and experts. Okay, so now, so in yesterday's workshop, what all did we do? So we have done imputation, right? In yesterday's workshop, we have done imputation. What is imputation? What does imputation mean? Imputation means filling the missing values, right? Exactly. Imputation means filling missing values. In yesterday workshop, we have done that in Pandas. Okay, and we have used this method fill now, right? So using sklearn, you do the same thing using simple imputer. Okay, and then we have learned how to handle outliers using clip function. Also, yesterday we have done encoding, right? What exactly is this encoding? Encoding means it is nothing but converting text data into numerical format, right? There were two types of orders: nominal order, which does not have any natural order. Okay, and for that in Pandas we use this method get dummies, but in sklearn we have something called as one hot encoder. Okay, and then there is ordinal order. So in Pandas we use map method, but in scikit-learn we are going to use this ordinal encoder. So in today's workshop I'm going to show you how to use this sklearn for data preparation. Okay, it is very simple, very easy, right? So here in today's workshop what we are going to do, we will be working on this data set mean median. Okay, so we will be working on this data set mean median to understand things better. So if you look at this data set, it is quite simple. Here there is one unnamed column is there. And then here we are having age of the person. The person's age is there and you can clearly see there are some missing values. And then fare is there. Okay. So maybe let's assume that these people are going to Titanic and this is their fare. And did they survive or not? One means the person has survived. Zero means the person did not survive. Okay, and how many what is the family size of this person? This person came alone, so family size is 1, and this person came with 3 other people, that's why the family size is 4 here. Okay, the data is quite simple to understand, right? So now what we are going to do, we are going to load this data. Okay, so in yesterday's class we have done ordinal encoding, nominal encoding, right? So what we are going to do here, let me load this mean median. I'm going to load mean median.csv into my Google Colab. After I load this, we are going to start working on this one. So I'm going to open this code. Okay. Before this, I want to know how many of you have practiced yesterday what we have discussed or either watched the recording. Let me just click on this. I'm going to load. How many of you practiced in this machine learning data sets? Here I'm going to load mean median. I'll click on OK. Great. Okay. So I want you guys to practice today's workshop also. Okay. Both the days are very, very important. So let's load this. I'm going to load this data frame. Here I'll do mean underscore median underscore df is equal to pd dot read underscore csv. Here I'm going to read this. Here I'm going to open this one, copy this path, paste it here. After this is done, here I'm going to print this mean median df. Now when I run this here, okay, notice this here it is showing me error PD is not defined. So basically what we have done, we have loaded these libraries yesterday. So I need to again run that code. Okay, I should again run that code for this to work. Either I can write it separately, or I can simply load this. Okay, here I'm going to load them. After I load this, now all these packages are loaded. Now once they are loaded, what I can do here, I can run this code. So now you are able to see all this data has been loaded. Okay, now after we load, here I want to see first 5 rows only. Okay, I want to check the first 5 rows only. What is the method? What is the method to read the first 5 rows? The method is dot head. Okay, here the method is dot head to read the first 5 rows. Okay, so now I'm going to run this. Do you guys want me to send the data set? Okay, what I'll do, just like yesterday's workshop, first let me complete this, and after that I'll give you guys recording and data set. You guys can do it along. Okay, so today's workshop is going to be short, probably only 1 hour workshop. Okay, first pay attention, listen to this. I'm going to send the recording and I'll send the data set. You guys can practice it along. Okay, later after this. Okay, now here head means it will give me first 5 rows, and then tail is there. Tail is going to give me the last 5 rows. I'm going to run this. So now tail is giving me the last 5 rows. Okay. Now, what do I want to do? I want to check which column has missing values. Okay. And how many missing values are there? How do I check this? I want to check which column has missing values and how many missing values. In yesterday's workshop, we have seen here I need to do df.isNull.sum. What this is going to do, this is going to give me the missing values. Look at this. Age column has 177 missing values. Okay. And fair column has 45 missing values. This has 177 missing values and fair has 45 missing values. Okay. Now let's fix this missing values. Okay, so let's fix this missing values. So now what we should do, before we try to fix the missing values, what we should do, here we know that fair and age both are numerical values, right? But should we use mean, median, or mode? What should we use to fill the missing values? Okay, so what did I say yesterday? We need to check whether there are outliers, right? We need to check whether there are outlier or not. So how do we check whether there are outlier? Here I need to do mean median df. Mean median df. Here I need to create a box plot. sns.boxplot. sns.boxplot. Here mean median df. Inside this I'm going to pass the age. Now when I run this, so guys, tell me, does this have outliers or does it not have outliers? This has outliers or not? It has outliers, right? So should I use mean or median? Should I be using mean or median in this case to fill the missing values? Exactly. I should be using median because it has outliers. Okay. I should be using median because this has outliers. So let's find out the median. So let's also check for fair. Let's also check for fair. Here I'll do sns.boxplot. Here I'll put fair here. So now when I run this, so now this also has outliers. Okay. This also has outliers here. So now what we are going to do, we are going to use median in both the cases to fill the missing values. Okay. We are going to use median in both the cases to fill the missing values. So here what I'm going to do, here, what I'm going to do. So as I've discussed here, in yesterday's workshop, we were not using scikit-learn, right? We are not using scikit-learn. So here to fill the missing values, we were using Fillna. But here in today's workshop, we are going to use sklearn for imputation to fill the missing values. So here we are going to use simple imputer. Okay. So here in this, we will be we'll be using simple imputer. So here what I'm going to do from here, let me write the observation. Here text, what is my observation? My observation is we have outliers in fair and age both. Okay, we have observation is we have outliers in fair and age both. So we have to use median in both as both have outliers. Okay, this is what we should do. So now here from sklearn dot impute. So basically, I don't want to import this entire sklearn library. From this, I only want to get this impute. So from sklearn dot impute, from this, now this is going to give me simple imputer. Now this is going to give me the simple imputer. Okay, simple imputer. Okay, so now here let me run this. So from sklearn.impute, here I'm importing simple imputer. Now what exactly is this? This is a class, right? This is a class. So now here what strategy we are using? So here because they both have outliers, here inside this I need to give strategy as median. Okay, so I'm going to use median strategy to fill the missing values. Like that is why here I'm giving strategy equal to median. Okay, so now here I'm going to give simple imputer. So I'm going to store it inside the simple imputer. Done. Now what this line of code will do, now this is going to help us in fixing the missing values. Okay, now this simple imputer has a method called as simple imputer dot this has a method called as fit transform. Okay, this has a method called as fit transform. So here I'm going to use this method fit transform. Inside this, what we should do here, I want to first fill the missing values of age, right? So here what I need to do, sort fit transform mean median df mean median df. This time what we should be doing, pay attention here. In this case we should be passing 2D array, right? Yesterday's workshop we are passing only one, right? So when you are working with this simple imputer, this time you should be passing 2D array like this. Okay, now after this is done, what I should do, I should just run this. So now you'll notice that here what this did, this simple imputer, it has automatically found out the median value, and wherever there are missing values, it is putting that median value in all the places wherever there are missing values. Okay, now after this what we want to do here, if you observe there are still missing values in this df mean median df dot is null dot sum. So now this is just giving me result. If you observe here, this age still has missing values. Okay, so now what this will do, this column you're seeing, right? This will just show you a result where how the age column will look like if all the missing values are filled with medium. But this does not update the original array. Okay, this does not update the original data set. If you want to do that, what you should do here, mean median df, inside this square bracket I need to pass age. Now when I run this, now we have made the in the original data set, the age column is now replaced with a column where all the missing values are filled. Now when I run this, you'll notice that, did you see there are 0 missing values in this age column. Now all the missing values in the age column are fixed, are replaced with the median value. Okay, now the same thing we should do for fair as well. Okay, last time what did we do? Last time we were manually calculating the median, and then we used to fill that median value in the fillna method, right? But here we don't do that. This fit transform automatically find out the median. Okay, median value, it automatically find out the median value and fill in places wherever there are missing values. Okay, that is what this simple imputer does. Okay, now same thing we are going to do for fit transform also. Here I'll do si dot fit transform. Again, we are going to use this same method si only. Okay, so here I'm going to do simple imputer dot fit transform. Inside this mean median df, inside this double square bracket, and here I'm going to pass fair. Mean median df. So I'm passing fair. Now when I run this, now you'll notice that, did you see here I'm getting a result where all the missing values in fair are filled with the mean value, sorry, median value. Okay. Now after this is done, I want this change to be updated in the original data set, right? So here I'm doing this. Fair is equal to, now when I run this, after this, let me check if there are any missing values. Here I'll do mean median df dot is null dot sum. Let's see if there are any missing values. Now, did you guys see here? We have filled all the missing values in age and fair by using sklearn simple imputer. Okay. Was this clear to everyone? How did we implement this? How did we fix the missing values? Yes. Okay, great. We have used median. We have used median. Why did we use median? Because it had outliers. Okay, because it had outliers. So now we know when to use mean, we know when to use median, right? We use median when there are outliers. When we have outliers, then we use median, right? Okay, and if we don't have outliers, then we use mean. Now when should we use mode? Mean, median and mode, right? We use median when the column is numerical and then there are outliers. We use mean when the column is numerical and it does not have any outliers. When should we use mode? Exactly, we should use mode for categorical values. Okay, we should be using mode for categorical values. Exactly, that's correct. Okay, let me write here imputation. We should go for mean when column is numerical and does not have outliers. Okay, and then we should go for median when column has numerical values and does have outliers. And then you should go for mode when column has categorical values. Categorical values means text values. Okay, now when you're having text values, there is no point of outliers. You will get outliers only when you're having numerical values, right? There is no point of this categorical values based on text column. So now what we will be doing, we will be working on one more data set, which is mode.csv. So let me just open this mode.csv. First, let's understand this data set. Okay, and then we are going to start working on this. Now, if you observe what is happening here, in this you're having fireplace, some column fireplace QU is there. Okay, in this, if you see what is happening, there are a lot of missing values, and this column is categorical. This column is text column. Similarly, this column is there. We still don't know if this has missing values. See, this has missing values. And also sale price is column is the numerical. We still don't know if there are any missing values in this. Okay. Now what I'm going to do, I'm going to load this in my Google Colab. Okay. And then we are going to analyze this data. We are going to see what is happening. So let's load this mode.csv here. In this, I'll click on mode. I'm going to click on open. Okay. So now here, what I'm going to do here, I'll do mode_df. Mode_df is equal to pd.read_csv. Inside this, here I need to pass copy path. Inside this, I need to pass this and then let me just print this. Okay, here we have loaded it successfully. Okay, now let's check how many missing values are there. Here I'll do more df dot is sum is null dot sum. Okay, more df dot is null dot sum. Now when I run this, here you'll notice that what is happening in Fireplace QU there are 690 missing values. In Garage Call there are 81 missing values. Okay, and let's see if that is categorical or numerical column. So Fireplace is a categorical column, and then Garage Call is also a categorical column. Okay, so now what we should do. So now let's see what all types of values are there. In this Fireplace, let's also see the shape of this data. How many rows are there? There are 4 columns. How many rows are there? We'll see. Now when I run this, there are 1460 rows. Okay. So we should not entirely delete this column. So the common understanding is if there are more than 70% of the missing values, then it should be deleted. Right now, this is not 70%. Okay, this 690 is not 70% of this. So we should not entirely delete this column. We should try to fix this. Okay. Now, in this case, let's see what all types of values are there in this Fireplace. So mode underscore df. Inside this, I'm going to pass Fireplace QU, and then here I'll do value underscore counts. Now, when I run this, here you'll notice that in this Fireplace, there are 380 GD values, 313 TA values, and then 33 FA values, and 24 EX values, and 20 PO values. Okay, that is what is happening in this Fireplace. So now what we should do, because this is a text-based column, right? Because this is a categorical column, what we should do, here we should use mode. You should go for mode when the column is categorical values. Okay, in this case, we should go for mode. Now what we'll do, let's find out the mode of this column. Here, mode means what? Any idea what is mode? Mode means in this column, which value is getting repeated the most. Okay, if you see GD column is getting repeated the most, right? So here, mode underscore df, okay, dot mode. Now when I run this, you'll notice that here I'm getting GD. Okay, here I'm getting GD. In this, I don't want to get everything 0. Now when I did this, here I'm only getting this value GD. Okay, and then here I'm going to store this inside a variable mode underscore value equal to this. Now when I'm running this, you'll notice that here I'm going to get only this GD value. Okay, right? So now what I'm going to do, wherever there are missing values, I want to fill all the missing values with mode. Okay, so here I'm going to do mode underscore df. Inside this Fireplace QU dot fill now. So now wherever there are missing values, all the missing values will be replaced with this. Okay, why did I took 0? Now see, why did I took that as, if I don't take that, here it is showing me this entire thing. See, here it is showing me this Fireplace QU column 0 index. It is showing me this structure. I don't want all this. I just want to get this value GD. It is there in 0th position. Now when I did this, here I'm getting this. That is why I've done that. Okay, let me store this inside mode value. So inside this, only that value will be stored. Now what this fill now will do, what all missing values are there in that column, in this Fireplace QU column, all the missing values will be filled with GD. Okay, so let's run this and check. Here what I'm going to do, let's run this. Now when I run this, you'll notice that all the missing values are filled. In this column, all the missing values are filled with the GD value. Okay, and then I need to update the original data frame. So here I'll do df more df of this equal to this. Now when I run this, after this is done, now what we will do, let's check if they're actually filled or not. Mode underscore df dot is null dot sum. Okay, let's run this. Here, did you notice what happened? All the missing values in this fireplace QU, all the missing values are filled. Okay, now there are 0 missing values. Okay. Now what we should do? We need to do the same thing. We need to do the same thing. Can we use simple imputer for, yeah, I'm going to talk about that only, Kirti. Here we have used fill now. Now I'm going to show you how to use simple imputer to fill the mode values. Okay. But was this clear to everyone? Did everyone understood till here what we have done? Yes. Okay. Great. So now if you observe, still I did not use sklearn. I still did not use sklearn here. Okay. So here I've used simple fill now only. Now what we are going to do, there are missing values in this garage call, right? There are 81 missing values in this. Now this time we are going to fill this using simple imputer. Okay. So now we are going to use simple imputer to fill the missing values of this garage call. Okay. So here what I'm going to do, here I'll use simple imputer. In this, I'm going to pass strategy. This time, the strategy should be mode. This time, the strategy should be mode. Now, here in this, we don't have mode. We don't have something like mode. So what we need to do, here we need to pass most frequent. Here I need to pass most frequent. And then using this class, here this is going to return me mode underscore si equal to this. Okay. So now using this dictionary, okay, this is going to give us methods. Okay, using that, we are going to fill the missing values in this garage call. Okay, so in this, what I'm going to do, simple here mode underscore si. This has a method called as fit transform. Inside this, what I should do here in this mode underscore df, mode underscore df, inside this, here I need to pass this garage call. Okay, so now what this is going to do, it is going to find the mode value in this, the most repeated. Okay, and then it is going to fill all the missing values in this garage call column with the mode value. Now when I run this, here we are getting some error. Let me see what error we are getting. Okay, here I need to put double square bracket. Here now when I run, you'll notice that here I'm getting the column where all the missing values are filled with the mode value. Okay. After this, what is the next step? The next step is this is giving you result. And here I'm going to do mode underscore df. In this garage column should be filled with this result. Now when I'm running this, here still we are getting error. Why we are getting error? Okay, here also we need to have double square bracket. So now if you see for fireplace, when we were putting the result into the original data frame, we had to put only one value. But when it comes to mode, what we should do, we need to put double square brackets. Now after this is done, so now you'll notice that all the missing values are filled. So let me show the mode underscore df dot is null dot sum. So now you'll notice that all the missing values are filled in this. Okay. So let me just repeat this once again. Now what I'm doing here. So now this garage call had missing values, right? This garage call had missing values this time, but this garage call, this column has text values, okay, categorical. So in this, obviously, I cannot use mean or median. So I have to go for mode. Okay, so that is why here what I'm doing, I'm using the simple imputer. This time the strategy is mode, right? But we don't have mode here. We have something like most frequent. Now this using this, what we are doing, using this mode underscore si, inside this has a method called as fit transform. Inside this, if you pass this column, what it will do, it will automatically calculate the median value. It will automatically calculate the mode value, most repeated value, and then fill all that column with the mode value, most repeated value. After this, we are simply updating the original column. Okay. After that, when we look here you'll notice that we have filled all the missing values of fire call and garage call. Okay. Now your data is there without any missing values. Okay. Is this clear to everyone? What we have done? How did we fill the missing values using simple imputer? Okay, great. Guys, now what we are going to do, I'm going to show you how to do encoding. How to do encoding using scikit-learn. Okay. Now we are going to learn how to do encoding using scikit-learn. Okay. So here I'm going to put plus code. In this, let me create a data here. So here I'm having a dictionary of lists. Okay. So here I'm going to have country. So country is India, USA, Canada, again India, and then again USA. Okay. I'm having this comma. Now here I'm going to have education level. The first person is doing bachelor's. Second person master's. Third person PhD. Fourth person is doing PhD. Fifth person is doing bachelor's. Okay, then here I'm going to put salary. Here I'll give 50,000, 70,000, and then 80,000, then again 60,000. Okay. So now here I'm having this. Let's convert this to data frame. How do we do that? PD dot data frame. Inside this, I need to pass the data. Now here, this is converted to data frame. Okay. So now what is encoding? In yesterday's workshop, we have seen what is encoding, right? Encoding means converting categorical values into numerical values. Okay. Converting categorical values into numerical values is called as encoding. Okay. So now there were two types of encoding: ordinal encoding and nominal encoding. Okay. So can you guys tell me which column is nominal and which column is ordinal? There are two categorical columns here. Okay. Which column is ordinal column? Which column is nominal? Which is nominal? Which is ordinal? Exactly. This column is ordinal. This has an order. And then this column is nominal. This column is nominal here. Okay. So this is what it is. Now in pandas, okay, in pandas, what did we do? In pandas, we have used pd dot get dummies, right? We have used pd dot get dummies. Okay. But in pandas, what did we do? In pandas nominal, for nominal column in pandas, for nominal column, we use pd dot get dummies, and for ordinal, we were using map. For ordinal, we are using map, right? But in scikit-learn, Okay, let me actually write it down here instead of putting this like this. In pandas for nominal, we use pd.getDummies. Okay, so pd.getDummies, and ordinal use map. Okay, in scalar for nominal, we use one hot encoder, and then for ordinal, we use ordinal encoder. Okay, right. So now here for pandas for nominal, we use pd.getDummies. For ordinal, we use map. In scikit-learn for nominal, we are using one hot encoder. For ordinal, we are using ordinal encoder. Okay. Now here, what I'm going to do from sklearn dot preprocessing, here I'm going to use import ordinal one hot encoder. Okay. So here this I'm going to import one hot encoder. In this, I'm going to import this ordinal encoder. From this here, I'm importing ordinal encoder. Okay, let's run this. I made a mistake here. Okay, it should not be dot. So here, what I'm doing from sklearn.preprocessing for nominal one hot encoder, for ordinal column ordinal encoder, right? So here from sklearn.preprocessing, I'm importing both one hot encoder and ordinal encoder. Let me just run this. Okay, after I run this, now what we should do? Now for education level, now this education level is what? This education level is ordinal column, right? For ordinal column, what we are going to do? We are going to use ordinal encoder. Okay, so here, what we are going to do? Here, I'm going to do first. Let's do for country first. Okay, here this country is a nominal column, right? For nominal column, we are going to use one hot encoder. Let's apply for nominal column. Here I'll do one hot encoder, one hot encoder. Inside this, here I need to pass parse output equal to false. Okay, and then this is going to give me a dictionary, one hot encoder. Now this has a method called as fit underscore transform. In this, if I pass this, I've stored inside this. Once I've converted this to data frame, I'm going to store it inside df. In this, using one hot encoder, we are going to convert this text to numerical format. Okay. Yeah, I'm going to talk about that, Srinidhi. Why did I pass? So in this one hot encoder, what I should do df of, first we are fixing the missing, first we are working on country column. Country. Here I'm going to pass country. Okay. So now what this is going to do, let me just run this. So as did you see here, I'm getting something like this. Did I give? Okay, okay. Here India is capital. Here it is small, right? I need to run this again. I should make sure that the spellings are correct. Okay. Even the casing is important. So I'll run this again. I'll run this again. So now here that country column you are seeing, right? Country column is getting converted like this. So in the first column, what did we have? What did we have in the first column? Here in the first column, we are having India, right? Let me just print this. So now look at this data frame. In the first column, what did we have? We have India, right? We had India here. So now India is being shown like this. India country is being displayed like this. India, USA, Canada. So now first value is India. Now India is being represented like this. USA is represented like this. And then Canada is represented like this. So now why is India value represented like this? What is the 0, 1, comma 0? Why it is represented like this? When why is USA represented like this? 0, comma 0, comma 1. And why is Canada represented like this? So now see, if you arrange India, USA, and Canada in alphabetical order, if you rearrange India, USA, and Canada in an alphabetical order, so now in an ascending alphabetical order, what is going to come first? If you arrange this in alphabetical order, here Canada is going to come first, right? Canada is going to come first. After this, India is going to come. And after that, USA is going to come, right? So now if you observe what is happening, India is coming in second place. India is coming in second place, right? That is why here it is representing India like this, okay? If you observe India, how it is representing, can you see 1 is coming in the second place? Because first value is India, Canada is 0, it is not Canada, India, it is India, that's why 1, and USA, it is not USA, that's why 0. Now, if you look at USA, USA is coming at the last. That is why 1 value is put at the last, okay? And after that, Canada is there. Canada value is coming at the first, right? To represent that it is Canada, 1 value is coming here. It means that it is Canada, it is not India, it is not USA, okay? That is how these values are being represented, okay? Did it make sense to you guys? Is this clear? Now look at this next one. Next is again India and USA. So India is second value, right? That is why 1 is coming. And USA is the third value. That is why it is coming last year. It means that it is India, not USA, not Canada. Last one, it is not Canada, it is not India, it is USA. This is how this categorical column, is converted and it is made look like this. Okay. Now this categorical column is converted and it is made to look like this. Is this clear to everyone? How these values are being shown? Yes or no? If we have 6 different, then 6 different values will come. Okay. Right. Now, in this case, what we should do now here, what we should do here, I need to store this inside the encoded. Let me store this inside encoded country values. I'm going to store this inside the variable encoded 0, 1, 1. At second place, what were you getting? So I'll repeat this once again. Here, what countries are there? India, USA, and Canada, right? If you put this in an alphabetical order, first you're going to get Canada like this, and after that India, and after that USA, right? So now Canada is coming in first place, India second, USA third. So now this first one, here you're getting India in the second place, right? Here you're getting 1 in the second place. It means that it is India. Now look at this. Here second one, 1 I'm getting in the third place. Okay. Now in this case, what is going to happen? USA is going to come third. If there are 6 countries, then first they all will be arranged in an alphabetical order, and then here you'll get something like this. This is how it will be represented when you're having 6 countries. Okay. It is just showing us like this. Once we do encoding, I'll show you how to put this in the original data set. Then it will be cleared. Then you'll not get 0 dot and all. Okay. Right. So now here what I'm going to do, one hot encoder inside this. I'll store all the encoded values inside this variable, encoded country values. After this is done, what we should do, here I'll do pd.data frame I'm going to represent all these encoded values in a data frame, pd.data frame, encoded country values. Now, when I did this, here they are being represented like this. Okay. They are represented 0, 0, 1, 0. All the values are being represented like this. Now, in this, what should happen here? The first column is representing Canada, right? Whether the country is Canada. Second column is representing India. And then third column is representing USA, right? That is what is happening. So here I should show country Canada, country India, and then country USA. That is what I should do. So for this, we should be doing here. After this, here I need to do columns equal to one hot encoder dot get featured names out. So in this, what I should do here, I need to pass this country column. Okay. Now when I'm doing this, here you'll notice that, see what is happening. It will automatically pick out the column names from this country column. It will automatically get the column names. And here it is putting country Canada, country India, and then country USA. Like this, what is happening? All the values column headers are now being shown like this: country Canada, country India, and then country USA. All the values are represented in this format. Okay. And now what did I want to do here? I'll store this inside the new data frame. Here I'll show new, this data frame I'm getting. I'm going to store this inside this new data frame. Okay. Now when I run this, I've stored this entire thing inside this new data frame. Let me run. So now my new data frame is looking like this. Okay. Now what do we want? I'll show you the original data frame. In this, what did we want? We want this country column. Text column should not be there, right? Here, this country is a text column. Here, this should not be there. In this place, what do we want? We want these encoded values. I want this data frame to be put here. After this salary, here I should get country Canada, country India. Here I should get country India, and then country USA. I want this column to be removed, and after this, I want these columns to come here. In this case, what is going to happen here? We are going to remove the categorical column, and then we'll show all the numerical values, right? So here, what I'm going to do, here I'm going to drop this column. This country is categorical, right? Here I'm going to drop this. Here I'm going to do df dot. Here I'll do df dot drop. Here I'll put columns equal to what column I want to drop. Here I want to drop this country column. Here I want to drop this country column, and because I want to make the changes permanent, here I'll do in place equal to true. Here I'll make in place equal to true. Now when I run this, here, let me see the original data frame. No, it will not increase the column. Instead, this is how we should do. Okay. We will remove the unimportant columns. I'll show you. Okay. Here, 3 columns are there. We don't actually need 3 columns, right? We don't actually need 3 columns here. We can actually remove 1 column from this. In this, we actually don't need this country USA. Even if we remove this, even if this is gone, if the country Canada is 0, country India is 0, automatically understood that it is country USA. Okay. Here also, if they both are 0, it is country USA. So there is no problem if you're having more values. What is important is we should have numerical values. We should not have categorical. Okay. So after this is removed, see, in the original data frame, we have removed that country column. After this new data frame is there, right? This new data frame should be coming after this. And how do we do that? We need to concat. We need to combine these two. Okay. How do we do that? Here, I'm going to show pd dot concat. Okay. I want in this here, I need to pass the parenthesis. And in this, I need to pass the data frame and then new data frame. Okay. And then here I need to do comma access equal to 1. Now when I run this, you'll notice that they both will get combined. See, here look at this country column is removed. And in this place here, I'm getting these three columns. Okay. The text based column is removed. And in that place here, I'm getting these three columns. Okay. That is how I'm going to remove this. Access equal to 1. Why did I pass access equal to 1? Because I want these two data sets to be combined column wise, not row wise. Okay. One data frame, second data frame is there. I want them to be attached wise, not one after another. Okay. That is why here I've given access equal to 1. Yeah, I'm going to talk about that, Srinidhi. Just give me some time. Okay, we'll talk about that. Why did I pass like this? Okay. Now, what we should do, we should also pass education level. Okay. We should also convert this education level into numerical format. How do we do that? See, here, this education level is ordinal, right? In this case, I should not use one hot encoder. Here, I should be using ordinal encoder. Okay. So here, what I should be doing. Yeah, let's fix this. Here, code from in this, I'm going to do, we have already imported ordinal encoder, right? Ordinal encoder. Inside this ordinal encoder, what all different types of education levels are there? Here, bachelor's is there. I want to put this first in the order. So inside this ordinal encoder, I need to pass what all different types of values are there by using categories. Categories equal to, here I need to pass 2D array. Inside this, I need to pass bachelor's. I want this first in order. And after that, what do we have? We have PhD. We have masters. We have masters here. And then after that, we are having PhD. Okay. So bachelor's, masters, and then PhD. Okay. This is the order. So now once this is done, let me store it inside encoder. Okay. So I'm going to put this inside the encoder. Once this is done, what we should do here, this encoder now has a method called as fit transform. Encoder dot this has a method called as fit transform. Inside this, what we should do, inside this one hot encoder df. So now what this is doing, so if you observe here, this has only got us the result. This has only got us the result where all the text values are converted to numerical. But this is not updated to my original data frame. Okay, this is not updated to my original data frame. So let's actually store this inside this variable one hot encoded df. One hot encoded df. Now when I run this, and now here I'll do df is equal to one hot encoded df. Now this is replaced. Now when I'm printing the original data frame, it is looking like this. Now my original data frame looks like this. Okay. Now here, ordinal encoder, what all categories are there? I'm passing all the categories here. After this, encoder.fit transform. Here, inside this, here I need to pass one hot encoded df. Inside this, here I need to pass education level. I want these values to be replaced, right? So here when I run this, education level. Now look at this. This is going to give me result. Did you see? For for bachelor's, it is giving me 0. For masters I've put second in the order. That is why for masters, it is giving me 1. And then for PhD 2, again, fifth value is bachelor's. For this, it is giving me 0. Okay. Like this here, it is giving me the values of zeros and ones. Okay. Now, once this is done, what we should do here, we did not want to have this, right? We did not want to have this education level. We did not want to have this, right? So this is a text-based column. I should delete this and then have this new column. So for this, what we should do here, I need to do one hot here. I need to do one hot encoded df, one hot encoded df. Okay. Dot drop. I want to drop that text-based column. Columns equal to, here I'm going to drop this education level. After I drop this, I want the changes to be permanent. So here I'm going to pass in place equal to true. Okay. And now when I drop this, here the changes are made permanent, right? So let me show it like this. Okay. Now that has been removed. Once it is removed, what is the next step? What we should do? Once it has been removed, okay. Once it has been removed, here all I need to do is pd dot. So here encoded fit transform. Let me show encoded education, encoded education column. This is the okay. I think I did not earlier. I should have stored it inside a variable. And I'm going to run this. So why this is giving me error is earlier I did not, store that inside a variable. That is why I'm getting this error. Let me just run this quickly. Now here, one hot encoded df. Now this looks like this. Okay. And after this, we are doing encoder. Here I'm going to run this. Now this is going to give me encoded education column. Okay. So now what I'm going to do in this, when I run this, here I'm getting this column. Okay. I'm getting this column here. Now after this, what I should do, here I need to drop this education level. Okay. I should be dropping this education level. In this here, I'm going to drop this education level. Now my one hot encoded df looks like this. In this, what I should do, in this here, that education level has been dropped, right? Now I need to concat this. So for this here, I need to do, in this, I'm going to open new code. pd.concat. pd.concat. Inside this, what I should do, one hot encoded df. Inside this, I need to pass encoded edu. Okay. This might give me an error. This is giving me an error because this should be converted to series format. Okay. This should be converted to series format and then that should be encoded here. Okay. What you guys do, you guys take this as a homework and complete this. Okay. What you should do, take this last part as a homework and then complete this here. You're getting this column, right? After this column, what should come? Let me remove this. Here in this, we have removed that education column. After this column, what should happen? This column should come. This column should come after this. Okay. You guys take this as a homework and complete this where this entire data set is now converted to numerical. That thing we have done using sklearn. Okay. Last one step is there. I'm leaving that to you guys. You guys take this homework and then put that column here. Will you guys do it? Will you guys do this last step? Yes. Okay. Guys, this is how we have completed this. Okay. This is how we have completed how to fill the missing values here. How to fill the missing values using sklearn. Okay. Right? Any questions, any doubts you guys are having? Just let me know if you're having any questions. Okay. So now, what is the difference missing values in pandas? So now here, sparse output equal to false. Here we have written sparse output equal to false, right? What does that mean? It means that the result will be in a array format. Whatever you are going to get, right? The result we want that in array format, right? Okay. So that is why here we are passing sparse output equal to false. Okay. Here, if you're passing that equal to true, if you're passing true there, so what it will do, it means that the result will be in the form of sparse matrix. Okay, so it will only save non-zero values. If you're only giving sparse output equal to true, it will only save non-zero values. Okay, so but we want the zero values also to be stored, right? That is why here I'll give sparse output equal to true. Okay, that is the reason. Yes, both are giving equal thing, just that earlier we are using pandas, now we are using sklar. Yeah, I'm going to share the data set with you guys. Don't worry. Okay, I'll share it with you. What is in pandas yesterday? What did we do? Let me just show you. In yesterday's workshop, look at this. It did not directly put what we are doing. We're still updating the original data frame. Okay, it did not update directly, right? We still had to do this. Okay. Any other questions you guys have? Okay. So, so guys, how was your workshop experience? This, whatever we are doing this, right? Whatever we are doing, all this is the steps before the machine learning. Okay. All this are the steps which are involved before we send our data to machine learning model. Useful. Okay. Great. So guys, just stop the recording.